Authentication and authorization are two separate processes that constitute the first line of defense to prevent private data from falling into the wrong hands and should therefore be a critical part of every organization's security strategy. Authentication is the act of validating that users are whom they claim to be and constitutes the first step in any security process. It can be single-factored, which means that only one verification will be performed in order to assert a user's identity, like for example signing in with an email and a password. Or it can be multi-factored, which means that two or more verifications will be made, involving for example the user's email and password plus a random verification code sent on the user's phone that only the user can see. Authorization, on the other hand, which always follows authentication, is the act of granting access or privileges to protected resources or functions. That process usually involves the use of a token, which is an encoded or encrypted string of characters containing secret information that proves the user's identity, and by extension, the set of possible actions on those resources. I'm Raz, and you're watching Explain It to a Duck. Let's start today by the most straightforward but also the less recommended authentication method called basic authentication. This method consists in the client placing a combination of username and password in the header of the HTTP request. To ensure safe transmission, this expression is encoded using the base64 encoding technique that converts a string into a set of 64 characters. Basic authentication should therefore only be used on top of HTTPS and TLS protocols, as the connection string can be effortlessly decoded using the base64 algorithm and is therefore not a good method to protect sensitive or valuable information. In order to avoid any confusion, let me briefly redefine the concepts of encoding and encryption, as they are of course two different concepts. Encoding is the process of transforming a piece of data into another form using an algorithm in order to make it either shorter or secret, but that can be easily reversed using the same algorithm. Its main goal being only to ensure data usability. Encryption, on the other hand, is the process of converting a piece of data called plain text into another form called ciphertext that involves the use of a secret key in order to be decoded, its main goal being to ensure data confidentiality. The bearer authentication is an HTTP authentication scheme that involves the use of security tokens called bearer tokens. Similar to the basic authentication, it involves the use of a token placed in the HTTP request header in order to allow the client to access protected resources. The difference being that this token is not client but server generated in response to a login request. A thing to keep in mind is that this type of token usually has a predefined validity duration measured in seconds, and that it will be considered expired by the system at some point. When this happens, the client must therefore request a new token from the server, which can be done in two ways. Either we force the user to go through the signing process again, asking for the credentials like the email and the password, or we can use what we call refresh tokens. A refresh token is a special token that is sent alongside the access token that has a greater validity duration and that is used to transparently request new access tokens whenever they expire without the user noticing or having to perform any actions. A good practice though is to invalidate these refresh tokens once they've been used in order to protect the application from token compromise and replay attacks. Now that we know how bearer tokens work, let me introduce you to an open standard for secured access delegation called OAuth. OAuth, which stands for Open Authorization, is a protocol specifically designed to work with HTTP and that specifies a process for resource owners to allow trusted authorization servers to issue access tokens to third-party clients in order to securely access protected resources. A few years back, web and mobile applications started to heavily interact with each other, eventually enabling users to use their account from one service in order to log in into another service. Like for example, using your Google account in order to connect to your favorite cooking app. To avoid asking for credentials every single time, third-party applications used to store users' passwords without encrypting them, which, aside from the security issue, implies that these applications were freely able to access any protected information. To address this issue, the OAuth protocol was therefore created in order to allow interactions between applications to take place in an optimal security context. The OAuth protocol involves four actors: the resource owner, the client, the authorization server, and the resource server. Without going into technical details, here's how the auth protocol works. First, the client, which is a third-party application or server, sends an access request to the resource owner, which is the user. The client will then query the authorization server, which in turn will respond with an access token. And once the token is acquired, the client is finally able to retrieve the protected resources by querying the resource server. Now that you have a pretty solid idea of what tokens are and what they're used for, let's have a closer look at one that's considered to be the industry standard called JSON Web Token. A JSON Web Token is a compact, self-contained, and digitally signed token that uses the JSON format to transmit information between parties. Beyond its encryption method, what makes it so popular is the use of the JSON format, which was way more compact than XML, for example, which makes it very easy to manipulate and to use, as JSON parsers are very common in most programming languages. It is composed of three parts: the header, the payload, and the signature, each part being separated by a dot character. The header is a base64 URL encoded object consisting of two fields, the type of token and the signing algorithm. The payload is also a base64 URL encoded object containing pieces of information about an entity, which is usually a user, and additional data called claims. These claims can be of three types: registered, public, and private. Registered claims are non-mandatory and predefined claims that can be specified to ensure interoperability with third-party or external applications, such as the issuer of the token or its expiry date. Public claims are usually generic non-sensitive information, such as a user full name or an email address. And finally, private claims are usually application-specific and sensitive information, such as an internal ID, for example. Finally, the signature is created by using a combination of the algorithm specified in the header, a secret value, and the dot concatenated value of the encoded header and payload. When combining all three parts together, the header, the payload, and signature, we end up having a string that looks something like this. And the last thing I'd like to talk about today is API keys. An API key is a unique identifier, usually randomly generated, that is used to authenticate and grant access rights to a program that's calling an API. Indeed, unlike authorization tokens, API keys are specifically designed for projects and not users, as they're not as secure simply because their value can be easily retrieved within the source code. Beyond helping with identifying the project that makes the API call, they're also used to track and control how this interface is being used, as they help restricting IP ranges and operating environments. They enable the blocking of anonymous traffic that can be an indicator of potentially malicious activity. They help with API consumption by controlling and limiting the number of calls made to the API. And finally, they help to analyze and debug issues one or more clients may experience. A last thing to note though is that API keys don't usually expire in contrast to tokens, but can be easily deactivated just by erasing them from the database. And that wraps it up for today, guys. Thanks for watching. Feel free to share, like, and comment this video if you find this content useful, and see you in a week for another episode of Explain It to a Duck. Cheers!